In this video we'll look at how to simplify ratios that have special angles without using a calculator. Now first of all, our special angles are as follows. It's 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. And the first thing we're going to do is for these three special angles, we've got two triangles that we're going to draw, a 30-60 degree triangle and a 45 degrees triangle. Now, easiest way to remember how to draw them, we draw a square and we draw a triangle. Now, the square has sides of 1 and the triangle, the equilateral triangle, has sides of 2. Now, a square has 90 degree angles and an equilateral triangle has 60 degree angles. And then what we're going to do is we're going to halve each of them. So we halve this square and we halve this triangle. Now once we halve it, if this is 90 degrees, then this angle then becomes 45 degrees, both top and bottom. And here, if we halve a 60 degree angle, we get 30 degrees. And then if I halve this side length, then that becomes 1. Then we can use Pythagoras. So we have 1 here, 2 here, and then if this is a right angle triangle, this length is then 3, square root of 3. And then if we have also a right angle triangle and you use Pythagoras, you find that this length over here becomes the square root of 2. So this is the two triangles that you need to memorize, know by heart. And then secondly, to find the 0 degrees and 90 degrees, we're going to use the trig graphs. So to draw the trig graphs, just the basics thereof, sine theta looks as follows. Now its period is 360, so it goes up to 360. And then we just label the rest of the axes. So if that's 360, the half of that is 180 and the half of that's 90. Then halfway between 180, 360, that's 270. And then it goes up to 1 and it comes back down to -1. So it starts at 0, then it goes up and it makes this wave going through 180 down to -1 and then back at 360. So that's what the sine theta graph looks like. And then to draw the cos theta, it's also got a period of 360. Halfway is 180, halfway of that is 90, and then that's 270. And then it also only goes up to 1 and down to -1. Now, cos theta starts at 1. So it goes down, goes through 90, then it goes around, goes down to -1 at 180, and then goes through 270, and it goes back up to 1 at 360. So this is what the form of the cos function looks like. And then finally, for the tan function, we can label the axis to 360, so half of that's 180, half of that's 90, and here we have the 270. Now the thing about tan, it is undefined at 90 and it's undefined at 270. So it never touches these lines, and then it's at 1, -1, but it doesn't, it goes past 1 and -1. So it also starts at 0, so it goes up from here, and then its period is 180, so every 180 degrees it repeats itself again. So then the rest of it looks like this, where it goes down here, and that's what the tan theta graph looks like. So as a summary, this is the two triangles that you need to know, and these are the three trig graphs that you just need to know the basics of how to draw them. Alright, so then for example 1, if I need to find sine 30, now sine 30's triangle is over here. So sine we know as opposite over hypotenuse, so opposite over hypotenuse, and from the 30 degree triangle, from this angle, the opposite is 1 and hypotenuse is 2, so we're going to write it as 1 over 2. That's the value for sine 30. And then for sine 90, we go to the sine graph. So this is our sine graph, and then at 90 over here we have it as equal to 1, so sine 90's value is simply 1. And then for example 2, so to find cos of 30, now cos 30, so once again we go to this triangle over here and we're working from the 30 degree angle, and cos we know as adjacent over hypotenuse. So the adjacent side is the square root of 3 and the hypotenuse is 2. So we have the square root of 3 over 2. And then cos of 0. Now this is our cos graph, and if we go to 0, which is over here, we see that it is 1, so cos of 0 is simply 1. And then for example 3, tan of 60. So tan of 60, that means we go to this 60-degree angle, and tan we know as opposite over adjacent. So from the 60-degree angle, the opposite side is square root of 3. So for the opposite, we've got the square root of 3, and then for adjacent, from this angle, the adjacent side is 1. So that's just square root of 3 over 1, which is then just square root of 3. And then for tan of 45, now we go to this triangle, the 45 triangle, and once again, tan is opposite over adjacent. So opposite from this angle is 1, and adjacent from this angle is also 1. So that's just 1 over 1, which just becomes 1. And then for example 4, so now we've got, this is normally what the exam questions looks like. So for 1 over 3, we just write that down, and then we're going to find the value for cos 30. So cos 30, we know cos 30 is adjacent over hypotenuse. So for cos 30, from the 30-degree angle, the adjacent side is this. So adjacent is square root of 3 over hypotenuse. Hypotenuse is 2. And then we add, now cos 0. Cos 0, at 0 cos is 1. And then we add sine 90. So at 90, sine is also equal to 1. Then simplifying, we have these two cancelling out. So we've got a half left here. Plus 1 plus 1, so that's plus 2. And then to simplify that further, this becomes 4 over 2. If I put this over 1, multiply top and bottom with 2, then this is 4 over 2, so 1 over 2 plus 4 over 2, and that gives us 5 over 2. And then for example 4b, now we've got sine 45, and we've got this square over here. So basically what happens is I'm going to rewrite it as sine 45, and then the square comes on the outside. So this is the notation for sine squared. You put the 2 over there, but it's actually saying that you take this ratio, sine 45, and you square the whole thing. So this is then cos 45, the whole thing squared. So now we're simply going to find our ratios. We know sine is opposite over hypotenuse, so we're going to this 45-degree angle, opposite over hypotenuse, so that is 1 over the square root of 2. And then we still square everything, so we've just replaced this with its ratio. Then plus cos of 45, so cos is adjacent over hypotenuse. Now adjacent, we have this as our adjacent side, this is our hypotenuse side, so adjacent over hypotenuse is 1 over square root of 2, and then we square all of that. And then to simplify that further, we say if we square 1, that just stays 1, and if we square the square root of 2, that's just 2. So plus, same here, square of 1 is 1, and square root of 2 is 2. So half plus half is 1.